8.4, Angles of Elevation and Depression. This is a continuation of 8.3, so we are going to need SOHCAHTOA to solve our problems. And don't forget to check your calculators. Sine 90 equals 1, and if it does not, go to your mode button and change to degrees. The objective of this lesson is to use angles of elevation and depression. Some vocabulary for us here. Angles formed above and below a horizontal line have specific names. An angle that is above a horizontal line is an angle of elevation. And an angle below a horizontal line is an angle of depression. So this should make sense to you. Elevation is how high up something is. Depression is like a depression is a hole or a dent. The DE prefix means that it goes down. And the important thing here is the horizontal line. So if we have our person on the ground here, and we're flying a kite, and our person looks up at the kite. And what that makes, we take our horizontal line here. Here's our horizontal line from the person's eyeballs. And that person looks up to see the kite. That is an angle of elevation. Now let's suppose we have a little ladybug here on our kite, and the ladybug looks out at this horizontal line. And the ladybug has to look down to see the person. That's an angle of depression. Now take a look at what we just drew here. What do we know about horizontal lines? That's right. They are always parallel, guaranteed. So if we have two parallel lines, what did we just draw here? We drew our alternate interior angles. So between these two figures, between the person and the ladybug, your angle of elevation and your angle of depression are going to be congruent. Yay! Let's look at a problem. What is the description of the angle as it relates to the situation shown? So what do we have here? We have a person in a balloon, and we have a horizontal line here from the person in the balloon, and we have, I believe that's a bird in the sky, and we have a horizontal line from the bird, and let's put, you're standing down here waving at your friend up in the balloon, so we have another horizontal line here. So angle 1, how is angle 1 formed? Angle 1, the bird is looking down at the person in the balloon. So angle 1 is an angle of depression from the bird to the person. What about angle 4? Well, you're standing down here and you look up to see your friend in the balloon. So angle 4 is an angle of elevation from the base of the mountain up to the person in the balloon. Let's just do these next problems here together. What about angle 2? Angle 2, what's happening here? The person in the balloon is looking up at the birds. So this is an angle of elevation from the balloon to the birds. And angle 3, the person in the balloon is looking down to see you on the ground. So angle 3 is an angle of depression from the balloon to the ground. All right, that was pretty easy. How do we use these angles of elevation? All right, you're standing here 53 feet from a wind farm turbine. Your angle of elevation, that means you're looking up to the hub of the turbine, is 56.5 degrees, and your eye level is 5.5 feet above the ground. So what do we have here? We have a triangle, and a fancy right triangle at that. We know that this is 53 feet away from the turbine. We have an angle here of 56.5 degrees. We want to know how tall the turbine is. This is X feet tall. So this looks like a SOHCAHTOA to me. We mark our angle, opposite, hypotenuse, adjacent. So we have opposite and adjacent. So OA means we use tangent. So tangent of 56.5 degrees equals opposite, which is X, over adjacent. We multiply both sides by 53. We get X equals 53, tangent 56.5. Put it into our calculator. We get 80.07, etc., etc. Now, is that how tall the turbine is? Well, sort of. What else were we given in this problem? We were given that your eye level here is 5.5 feet. So if X is 80 feet, we have to add on the 5.5 feet from the ground. So this is plus your eye level. So it's 80 plus 5.5. So our wind turbine is about 85.5 feet tall. That was fun. Don't forget the eye level. You are above ground. You have to count that length there. Ooh. All right. It looks like it's your turn. Pause the video and do the next problem. This problem was just like the one we just did. We see a rock climber on a cliff. We are looking up at a 32-degree angle of elevation. That means when we draw our picture, we know we have our horizontal line and we are looking up. And we know that we are 1,000 feet from the base of the cliff. So we want to know how high the rock climber is. That's X feet high. So I label opposite, adjacent, and hypotenuse. And I have opposite and adjacent. That means TOA. So I'm going to use tangent. Tangent theta equals opposite over adjacent. So tangent 32 is X over 1,000. Do the math. And we get X is 624 point a lot of decimal places. We're going to round that to one decimal place. We weren't told, so we could have used just nearest foot on this one, probably would be fine, but you know, 1, 2 decimal places is a good standard if you aren't told. So this is 624.9 or 625 feet. And don't forget, your eyes are not on the ground. So we have to add the 6 feet of eye level on. So that's about 630. We could have said 631 feet would have been acceptable as well. Don't forget to add your eye level on. All right, now on to angle of depression. Angle of depression means that we are looking down from our horizontal line. So we're going to have a horizontal line here, and we are going to be looking down. So that means our triangle is going to go this direction. So let's look at our problem. We are coming into an airport in Oklahoma. The pilot must begin a 3-degree descent starting from a height above sea level, and the airport is also above sea level. And we want to find to the nearest tenth of a mile. How far from the runway is the airplane at the start of its approach? All right, let's look at our picture here. Let's draw a picture. We have an airplane, and don't forget the horizontal line is coming from the airplane. And it is beginning a 3-degree descent. So we are looking at this angle here comes this way to make your angle of descent. That's the angle of depression. And we are coming into our airport. Now, how do we want to draw this triangle? Do we want to draw the triangle like this and use this angle? That's an option, right? It's a right triangle there. Or do we want to draw this triangle here? Which means that this is not the angle of depression. So we could either call this angle 87 degrees, or we can come down here and use this angle and make it 3 degrees. Either way you do this, it'll be fine. This is where you're going to make mistakes, is angle of depression. Angle of elevation is a normal triangle to draw. You're looking up. Angle of depression, if you're not careful, it'll get you. So let's just assume that we're using our 3-degree angle here on our triangle on the bottom. And what do we have as far as measurements? We know that we want to know how far is the airplane from the airport. And it doesn't say horizontal distance. It says how far does it have to fly to get to the airport. And we also know that the airplane's above sea level, but so is the airport. So we have to subtract these distances. So this is 1707 feet above the ground on this side. And we are looking for that hypotenuse over there. How far does it have to fly? So I'm going to label. Got my angle, opposite, hypotenuse, adjacent. Which one are we using here? We are using, we've got opposite and hypotenuse. So that means sine. So sine of 3 degrees is 1707 over x, and you can either put it over 1 and cross multiply, or you can multiply both sides by x, and then divide by sine 3, and we end up with x equals 1707 over sine 3, which is just a calculator problem. But then we want to know to the nearest tenth of a mile. Well, what do we need for that? We need to know that 1 mile is 5,280 feet, because this answer right here is in feet. So we divide by 5,280 and get about 6.2 miles from the runway. Now, we could have done this problem using the 87 degree angle, right? We could have done 87. Let's draw it elsewhere. We could have used 87. Mark our angle here. This is opposite, hypotenuse, adjacent. We are still looking for this. This would still be 1707. And this time we would have adjacent and hypotenuse, which would be cosine. So cosine of 87 is adjacent over hypotenuse. So x would end up being 1707 over cosine 87. Guess what? It gives you exactly the same answer when you put it into your calculator. So it doesn't matter which angle you choose. Be careful with your angles of depression and elevation. You'll probably be best off if this is your angle of depression. Draw your right triangle like you know how it is and use alternate interior angles to transfer the angle down to there. All right, so that's good. Looks like the last problem is all on you here. So pause the video, do the last problem. This problem was just like the last one. We had an airplane that sees a life raft, 26 degrees angle of depression, so we know we're looking down. Airplane's altitude is 3 kilometers. This time we want to know the horizontal distance. So that's important. So I draw my airplane looking down at my raft. I know that I am measuring 26 degrees down from the horizontal. So I use alternate interior angles to put my 26 down there. And 3 kilometers altitude, we're looking for the horizontal distance x. We have, I label my angle, opposite, hypotenuse, adjacent. We are using, we've got opposite and adjacent, so that means tangent. So tangent 26 is 3 over x. Do the math. We end up with x is 3 divided by tangent 26, which is your calculator, or use your trig table. And you get the airplane is about 6.2 kilometers horizontal distance. So we know that our little rescue ship here has to sail 6.2 kilometers to go pick up the people in the life raft. The boat's a little off there. There we go. All right, so it doesn't matter how you draw your triangle. You could have drawn this triangle here and used 26 here, and this would be opposite, this would be hypotenuse, this would be adjacent. Still going to be the same problem. You could have drawn this triangle here, and knowing that this is 26, you could have used, this is 64 degrees. And then we would have opposite, that's not an O. And then we would have opposite and hypotenuse and adjacent. Triangles need some right angles here. So in this case, in our first case here, this would be our 3 kilometers. This would be the horizontal distance. We would still have TOA, tangent of 26. It'd be exactly the same problem. What about this next one? If we're using 64, this is 3 kilometers. This is the x we're looking for. This is opposite over adjacent. It's still TOA, but this time it would be tan. Let's do this in a different color. Tan of 64, what would be opposite? X over 3. And then x would equal 3 tan 64. So it's still tangent, but now opposite and adjacent have changed. And sometimes I will actually look at my angles and say, do I want this angle down here, which is 26, which would put opposite 3 over adjacent x. Don't like my x on the bottom. I'm going to use my angle on top here, 64, which would put my opposite x over my adjacent 3. So we get exactly the same answer, 6.150911525. It's just an easier problem to solve. So, as I always tell you, good choices at the beginning, as in everything, makes things easier down the road. The only place you're going to have problems, once again, is angle of depression. Be careful with that. Draw, 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 label, label, label. Put things in color. Geometry's easier in color. So, be careful with these. Good diagrams will get you a long ways. And SOHCAHTOA is just awesome. Have fun on your homework.